also you can solve. This formula came up via this only, applying this formula only, putting a value a naught by k and putting t as t half. So either one you can use. It is upon you.
So sir, T half value is 100 seconds.
Ha ha. So
Yes.
that is why in the place of t, in the place of time, I have put it as 100 seconds, and in place of concentration of a which is remaining is a naught by 2. Okay, initial concentration was a, and time at which a becomes a naught by 2 as is 100 seconds. So in both formulas you will get the same answer. Got the answer?
Yes, sir.
Rishita?
Yes, sir.
Okay. So try to solve the second question. Answer me in chat. Second one. So first one easy, it was easy, right? You can do it by yourself.
Yes, sir.
Please try to do the second one. What is the answer? Please answer in chat box. I want to know the answer. Done? Rishita?
No, sir, I'm still doing.
There is no calculation, just think and you can comment on the answer. So see, in this question, the question is very tricky one. So question says is we have taken a in excess. Okay, so this a is in excess. So rate this rate law the will not depend on a. Okay, so it will become like this. So since this is not dependent on a, we have studied in earlier classes. You can revise it. So the order of reaction becomes 1. Okay, got it, Zana? Good.
Yes, sir.
Rishita, got it, Rishita?
Yes, sir.
I've already told that which is in excess or which is in solid, we have to neglect that, and order of reaction should be will not be dependent on that. Okay, got it, Rishita?
Yes, sir.
Please solve this question. The question is already given zero order reaction. Okay, and initial concentration is given, uh, and after 10 minutes means a is also given. Okay, you have to find half life and completion life. So half life is a naught upon 2k and completion life is a naught upon k, right? So please solve this. Done.
No, sir.
Design Arishita. What is the progress?
Solving, so 1 minute.
Mhm. So let's try solving this. So the zero order reaction is already given. So we will apply this formula. A is equal to A naught minus KT, right? Hmm?
Yes, sir.
0.08 is equal to zero point 0.1 minus K into T. T will be 10 minutes. Okay. So 0.02 is equal to K into T. So K will be what? 0.02 upon 10, which will be 0.002. Okay.
Yes, sir.
T half is A naught. A naught is zero point 0.1 upon KT. Sorry, A naught upon 2K. है ना? K is 2 into 10 to the power of 3 here. So it will be 100 upon 4, which is will be 25. Right?
Yes, sir.
Yes, sir.
Mm. So T half is this. So obviously T T T total is T completion is 50, right? 50 means without solving, है ना? Zaina, where have you done wrong?
So for the k value, um,
No, no, in the formula you have applied wrong, or the data you have done wrong, the calculation error or
the
some other error.
calculation error.
Okay. Okay, no problem. So understood?
Yes, sir.
Hmm. So see, one thing I want to tell you, like for example, if we have uh, initial concentration 100, and after some time, which is t half, it will become 50. Okay, so we can say that a naught upon 2k time has been, uh, after this time, that this concentration has become half, right? Yes or
Yes,
no?
sir.
And after a naught, this to complete this equation, another, if you spend a naught upon 2k time, then it will be, the concentration will be over, right? It will become 0, 100% complete, right?
Yes,
So
sir.
this is the same time for, this is like linear graph, as we know. So this will come linearly. You can understand it like, if you want to say that 25% is complete, so this time will be, directly we can comment that it is a naught upon 4k. Okay, for 25% completion, a naught upon 4k, this will be the, without solving also we can say this. Like for example, there is another example. If we will draw this, like for example, we have this. Okay. Mm, one- for example, these are equal intervals. Okay, so this is 100, this is 90, this is 80, this is 70, this is 60, and this is 50. Okay, in this question, let's try to solve this question through this method. Let's see. So in the zero order reaction, the initial concentration was 0.1. Okay, and after 10 minutes it has become 0.08. The question is, after 10 minutes it has becoming 0.08. So let's think. Here we don't know t half. Okay, let's do another way, like we have t half with us 25 minutes. So in 25 minutes, I'm just want to increase the, means the way you think now, that is why I'm just showing in this way. Like we have, in 25 minutes their concentration has become half. So in 25 minutes, for this is like, half the concentration has been reduced. So the concentration was initially 0.1, and here the concentration become 0.05. Okay, the concentration has reduced to half. Okay, and it has took 25 minutes. Okay, 25 minutes. From this we can conclude this, right, everybody?
Yes, sir.
The concentration has become half, 0.1 to become 0.05 in 25 minutes. Okay.
Yes, sir.
Hmm. So divide this in 5 parts. If you will divide in this 5 parts, you can say that in every 5 minutes, this is 5 minutes division. Okay, the concentration, एक second, for exactly in this between, ठीक है, the concentration bit will be 0.75, right? The concentration will be 0.75. Yes or no?
Yes, sir.
The concentration will be 0.75, and that time will be, time will be what? Since from this to this we have spent 25 minutes, so from this to this it will be 12.5 minutes, right?
Yes, sir.
Can we say or not? This is exactly like when you have studied a car is traveling at a constant speed. So what distance it will travel in this much hour with a constant speed. So this is happening like this only. Okay. So uh, in each 25 minutes, the concentration is becoming half. Okay. So we are getting that 25, the concentration was here 0.75. Okay. And the time was 12.5 minutes already gone. Okay. So before that, there was some 10 minutes, right? For 10 minutes, you can say that this much concentration is gone this side. Okay. So here, like zero point zero 0.08 is here. This is 0.08. So like 10 minutes is gone. Okay.
Yes, sir.
Or if you want to look in this way, if you want to look in this way, like every in every 5 minutes, 10 sorry, not 5, this is divided into zero point 0.1. This interval is zero point 0.1 minus 0.05 upon 5, this interval. Acha, don't do this, just you can use the formula and you can get the answer. Don't go through this way. Okay, because in boards now you have to solve the equation. You cannot directly write these things and get the answer. Okay. If you will go this means you have to use the formula and then proceed with the answer by this way. Okay.
Yes,
Unitary
sir.
method, if you will apply, then the answer will come right, but maybe teacher will cut your marks because you have not done the questions in steps. Got it?
Yes, sir.
So do the question in stepwise. This one. Try to solve this question. This question is direct. You have a minute to solve. How to solve this question? How you have solved Dana?
Service. I'm still doing it.
So the creative reaction, they're all given in mole per liter per second.
Hmm.
So that's in zero order.
Good. Rishita, means here we don't have to solve it here. Just look into the this unit thing which I have taught here. You can see. the order can be directly commented by the unit of k. Okay, if the unit of k is given, you don't have to look for the formula or data, nothing. If the unit of k is given, you can directly comment on the order of the reaction. Okay, and let me tell you, don't have to remember the general formula also. Just remember 0 and 1. Both are the most important ones, 0 and 1. Okay, because board exams are limited to these two only. Okay, and that's it. You will get the right answer, and the question is solved. Okay, ठीक है
Yes, sir.
Rishita? हाँ, the answer is zero order. Okay, so in the last class we were doing this first order reaction, in which we have gone to this. Okay, so this was the formula ln. Let me write it. It was like, means there are several ways. So I'm writing one of the way. Ln A is equal to ln A naught minus KT. Okay, this is the first order. We are going to see some graphs related to it. Okay, and then we will solve some numericals. Everyone understood the how to solve numericals for zero order? Hmm? Don't worry about this unitary method. Otherwise, you will get confused, and the number you are getting in the boards via step marking. Okay, so the question should be done in steps like this. Okay.
Yes, sir.
Mhm. And here you have to mention that TC is equal to 2 times T half. Then it will be like this, and this. You will get the answer. So let's see. We have to draw a graph with respect to. We have to draw a graph log of concentration versus time. Okay, so for this please see, we have to make graph this versus time. So ln, this is the graph we have to convert in so that you can understand it better. This is like y. Okay, and this is like c, because a naught is constant. This is kt will be mx. Why? T is like x in the x-axis. K is will be the slope, and this is the or you can write is it like एक second. No, formula is एक second here. फॉर्मूला तो सही है. Log a. एक second. उल्टा हो गया. ठीक है, log a naught minus kt होगा, ये उल्टा हो गया. ठीक है, so this one will be like this one, and y is equal to mx plus c minus c. Okay, so we will get a graph like this. Okay, in which this is y and the slope is m. So m will be what? This k, है ना? So this will like we have seen graph of this one for concentration in zero order, concentration A versus T. So the graph was like this. Okay, in zero order. Please try to remember, for zero order graph was like this, right? The concentration of A versus time was this. Okay, straight line with this one. Okay, and here the concentration versus graph is not like this. Sorry, here we are taking log of concentration of A versus time. So the graph will be similar. However, here was concentration, but in this it was log of concentration for zero for the first order. Okay, for first order. So if you will compare and study, you will remember the things always. So first order reaction will be log of A, and for zero order it will be only A versus T. Okay, yes or no?
Yes. Yes.
Yes, sir.
Ha. So try to compare, and you will get the answer in means you will get the correct answer every time. Okay. Now let's see. You have to draw some other graphs as well. So we have mm, from this formula, this formula, we will derive another formulas as well. So this is like log of A naught log of A is equal to log of A naught minus KT. Then after that we are uh, bringing this A naught upon A, okay, is equal to minus KT. Then we are doing like giving power here. So A upon A naught. Why we are doing this? I'm let you know. A naught upon AT is equal to E की power minus KT. Then A will be is equal to A naught E की power minus KT. Please see this. So we are getting what A is. So A is A naught into E की power minus KT. You don't have to remember each and every formula. You have to remember just one formula, and we have derived this from here. Okay.
Yes, sir.
Can you see this here? Why minus came? Because there it was A naught upon A. Here it is A upon A naught. That is not a big deal for you. The simple mathematical things you understand, right? So this is done. Are you
No,
okay with
sir.
this formula? Miss Formula, you
Yes.
have understood?
Yes, sir.
Okay. You don't need to remember the formula, but you have to understand the graph. Why we are means doing such a means again we are driving one formula, and because we have to draw a graph between A versus A naught versus time. Why we are drawing this? Because we have drawn the similar graph when we are doing this in zero order reaction. So here also you can see with time, as you will increase the time, you try to understand, as we will increase the time, as we will increase the time, this value will decrease, right? Since because the power, if you will increase the minus of power of E anything, the whole value will decrease, right? E की
Yes, sir.
power -1, E की power -2, E की power -3, the uh, the the values are getting down and down, right? So with time, this thing, with time, as we increase the time, the whole value will decrease, right? With time, the concentration of A will decrease. Yes or no?
Yes, sir.
Rishita, are you getting?
Yes, sir.
You want to repeat? Means
No,
you
sir,
want.
I got it.
So as the time is increasing, this whole value is decreasing. So it will decrease. Okay. So in with time, the value will decrease, and it is decreasing exponentially, not linearly, but exponentially. Okay. So let's see. As you put at t is equal to 0, the A will be value what? A naught. Why? Because at 0, e की power 0 is 1. So we will get A naught. Okay.
Yes, sir.
Ha. And if we will put t infinity, means at a very large time, है ना? So when we will put t as infinity, e की power minus infinity, है ना. e की power minus infinity will be what? E की power minus infinity will be 0. So overall the value a will become 0. So at infinite time the value will reach to 0 value. Okay, the our whole reactant will get exhausted. Okay,
Yes,
so
sir.
this is the graph exponential. At infinity they will touch the graph and the value of the concentration will become 0. Sorry, this is the graph. This is graph versus a versus time. So the at initially the concentration was a naught. As we know, at time 0 the concentration of a was a naught. Then by time when tending to infinity, that will become a the concentration of a will become 0. Got it? So formula we used here is a naught is equal to e की power minus kt. That's why we have derived the formula, uh, so that we can get the relation between time versus the concentration of reactant. Got it? Understood each and every part?
Yes, sir.
Yes, sir.
Hmm. So this is you know you can say exponential form, in exponential form, and this was integrated rate law. Integrated rate law. ठीक है? A naught, you people know that it is initial concentration, A is concentration to any time, T is the time, and K is the rate constant. Got it, everyone?
Yes,
Yes,
sir.
sir.
So this is the concentration with respect to time, and in this one the concentration with respect to time was a straight line. Okay, however in the first order reaction, when we will do log of this, then you will get the exact same reaction. Okay, but if you want to draw graph between concentration of A versus time, then you will get graph like this. Okay, exponentially. Understood the difference?
Yes, sir.
Yes, sir.
है ना? But if you have understood the difference, then it is well and good, because you have to compare their ठीक है. Done copying?
Yes, sir.
Rishita?
Yes, sir.
हाँ. Any problem in this? Any part?
No, sir.
Okay. ठीक है. Now we have to draw T half, means you have to understand the concept of T half, the half life in first order reaction. We have talked about in zero order, right? है ना?
Yes, sir.
Half life, first order. So in first order T half we are going to see. So the definition is same, time taken for 50% completion of reaction. Okay, so at T half you people know that the concentration of A becomes A naught upon 2. The concentration becomes half. Right? So uh, uh, the formula which we will be using to get this, एक second, TF, हाँ. So A becomes A naught upon 2. So we will apply this in formula. Uh, kt is equal to log of a naught upon a. This is the formula. kt is equal to a naught upon a, log of ln a naught upon a. This is log of n, or can say ln. Then we will since we have to find t half, so we will put t as t half. This will be ln only, your log a naught has become sorry, a naught is a naught only, a becomes a naught upon 2. Okay, so this one will be cancelled out. It is 1 by k here. Then what will be we will doing, t half is equal to 1 upon k. Okay, ln of 2. Okay, understood?
Yes, sir.
This is the formula. Or ln2 you can the value of ln2 is 0.693 upon k. So this is the formula you have to remember. T half for first order reaction is 0.693 upon k, or ln2 upon k. Please note it down. Some formulas which you have to remember is ln2 is like, you don't have to remember ln2. Log of base 10 is 2 is 0.3. We are going to use this formula today only. Log of base 3 is 0.477 or 0.48. Okay, these things are most important. And log 5 you can derive. How log 5 is log 7, let me tell you. You have this, these two should be remembered. Log 10 is 1, right?
Yes,
Log
sir.
so you can do this like this. If you want to find log of 5, log of 10 upon 2 is, you have to find this. So if you will solve log 10 minus log of 2, so log 10 is 1, log of 2 is 0.3, so log of 5 is 0.7. So these two are the most important ones. Every time you have to remember this, log 2 and log 3. Okay, log 2 is very important, and that's it. How 0.693 came? So it was like uh, means uh, log of ln is converted into log as 2.3 log of 10, 2.303 log of 10. So anything log of ln of something is 2.3 log of ln x is equal to this. This is the formula. Done copying?
Yes, sir.
Yes, sir.
So please note here that uh, T half in first order reaction is independent of initial concentration. Can you see there is no initial concentration in the formula? Yes or no?
Yes,
T
sir.
half is only dependent on the K value, right? It,
Yes, sir.
है ना? So only rate constant. So T half is independent of initial concentration in first order reaction. But in the zero order reaction, the formula was A naught upon 2K. So it was dependent on the initial concentration, right? Yes or no?
Yes, sir.
Huh.
Yes, sir.
Let's find T completion. Okay, so T completion. So at T completion, what will be A? The remaining concentration A will be 0, right? Yes or no?
Yes, sir.
So let's try to write this in formula. Kt is equal to uh, ln A naught upon A. Okay. So T is equal to T completion, T 100% is 1 by K log of A naught upon 0, right? This is log of infinity. So log of infinity is infinity only. Okay. And now something upon 0 is x upon 0 is infinity, right?
Yes, sir.
Yes, sir.
So log of infinity is also infinity. So T 100% is infinity. Got it?
Yes.
So you can say that uh, another note you can add that first order reaction, first order reaction will never complete. Yes or no? First order will the reaction will never complete. है ना? If you will see, there are some practical example in this world which goes through first order reaction. So theoretically, yes, they will never complete. However, practically, we don't. We study macro things only. है ना? Big somewhat we can measure, somewhat we can observe. So they becomes inobservable. So theoretically they will never complete, but practically yes, they are means complete. Okay,
Yes,
Yes,
understood.
sir.
sir.
So please note it down. Done.
Yes, sir.
Done, sir.
Hmm. So let's see what will be the graph between T half versus A naught. Okay. So we have seen that A naught, T half and A naught are not means T half do not depend on A naught, right? The initial concentration of A naught, है ना? Why? Because T half we know that it is only ln2 upon K or 0.693 upon K. ठीक है? Yes or no?
Yes, sir.
Yes, sir.
So when you will draw a graph between T half life versus the concentration of A, it will be a straight line. Okay, because it is not dependent on concentration of A. That is why it is constant with respect to concentration of initial concentration of reactant. Okay, understood?
Yes, sir.
Yes, sir.
And again, we are going to compare with zero order reaction. So it was like T half is equal to A naught upon 2K, right? Yes or no?
Yes.
See, bolo bhai. So
Yes, sir.
what you will see here is T half is proportional to A naught. T half is proportional to A naught. So it will be a graph like this. Okay. If something is proportional to like this, so the graph becomes like this. Since here it is not dependent on anything with a naught, so graph will be like this one. Okay, a straight line. ठीक है?
Yes, sir.
This one is very important. And done copying.
Yes, sir.
So let's see some example of first order reaction, as we have seen example of zero order reaction as well. So first order reactions examples are like this one is the most important one. You will again study this in physics, in radioactivity. Lots of equation. This only. Again, you will study this formula. T half is equal to 0.693 upon K. There the K will be replaced by the different name lambda. So ln2 by lambda or 0.693 upon lambda. All radioactive decay are first order reaction. First order reactions. Okay. Then we have decomposition. The first one is the most important one. Decomposition of N2O and N2O5. Hydrogenation of ethene. Hope so you are done.
Yes, sir.
Yes, sir.
So let's try a question regarding first order. Try this question. I'm writing this question. Write this with me. Value of K, which is rate constant, is 60 per second. Calculate time taken for so value of K is given. You have to calculate time taken from 5. The initial concentration was given as 5 gram. Okay, and the remaining concentration value is also given. It get reduced to 2 gram. Okay, the remaining concentration is also given. Zana, what is the, and Harshita, what is the order of the reaction? Can you guess?
One, sir.
How it is one? Zana, how it is one?
Um,
Rishita, you can also answer. Mhm. Can you see here again? Can you see my screen?
Yes, sir.
Yes, sir.
What I have shown here, please again see this again and again. I am mentioning. Can you see this? This. It says about the order of reaction. Just see the unit of K and you will get the answer. Now, can you comment? What is the order of reaction? Hmm?
1.
So when you have seen the unit of K, directly you can comment on the order of reaction. Okay, Rishita and Zaina?
Yes,
Yes,
sir.
Yes
sir.
or no? So the order of reaction can be commented that it is 1. Why? Because it is unit of K was given as per second. That is why the order of reaction is 1. Okay? Yes or no?
Yes, sir.
Yes,
The
sir.
question can be solved as zero order reaction also. But no, you have to solve it as first order reaction because the value of K unit is given as per second. Okay? So please solve the question. Can you solve the question?
Yes, sir.
Yes, sir.
Or I can, or shall I try first, or you can try it later?
Okay.
Okay, sir.
Means what you will. I think you should try it first. Okay, try it. The value of A is also given. Value of A naught is also given. The value of K is also given. You have to type, only calculate T. KT is equal to ln A naught upon A. Just put it in the formula and let me know. Rishita, are you stuck somewhere in the problem?
No, sir. I'm trying. I'm almost.
So you are doing some mathematical calculations, right? Or you have problem with the formula?
No, sir. I'm doing math.
Okay.
Mathematics.
So let's see. I'm trying this. Okay, we will solve another question. So KT is given as the formula I'm writing ln A naught upon A. Okay. The formula looks little easy going also. If you will add 2 point means other way to write is like 2.303 log of 10 a naught upon A. This is like looks like a big formula. That this is like a smaller formula. You can do further calculation later as well. So the value of k is not given here, so we will put k only. The time is 1 by t, temperature time, sorry, time is 60. Ln of a naught is given as 5 gram and 2 gram. Okay, this is the value. Then we will we will convert this ln in log of base. So we will put this as 2.303 and ln log of base 10 5 minus log of base 10 2. Just let me know, are we good till here? Yes or no?
Yes.
Yes, sir.
Okay. So further when we are solving this will be round of to 2.3 only, no problem at all. Log of 10 base 5 we have seen as zero point 0.7. Log of 2 it was like zero point 0.3. Okay. Yes or no?
Yes, sir.
Yes, sir.
Huh. So 1 by 60 is equal to 2.3. This will be zero point 0.4. Okay. And solve it. 15 है ना? So what you will get? Where you were stuck, Rishita?
Sir, I got that 1/60. The second last one.
In this step you were incorrect, or means it you were going good, means there was no problem.
No, I was going fine, sir.
Hmm. So this one will be like 15. If you want to solve this, actually, mm, there is some calculation you can do this. So you will get 15 to this 15.3 into 10 to the power of minus 2. Zana, where you have done wrong?
Calculation, sir.
Calculation error. Okay, since it was first first order reaction, so the answer will be in second inverse. Please note it down. Where you were have done calculation error, Zana?
I did not convert ln to log. I took it directly as log. So
Acha,
I did not
acha. No
convert.
problem. No problem. The value of ln you have to convert in log, then you will get
Yes.
the answer. No problem with the log thing.
No, sir.
Try to solve another question, then you will get to know means what is the progress. Done copying,
Yes, sir.
Rishita?
Yes, yes.
Okay. The question is, second question is, first order reaction is 40% completed in 40 minutes. Okay. Uh, Calculate K. You have to calculate K. Okay. Understood the question?
Yes, sir.
Huh. So can you see the value of A naught and value of A is not given? Yes or no?
Yes,
Yes,
sir.
sir.
Can you solve this without those values? I'm giving you a hint. Let value of A naught, है ना? You can take it as X, okay? Or take it as 100, whatever you wish. Okay. So the this value A is the remaining concentration, right? So this will become 0.6x, right? Everyone? Or you can say it has become 60. Yes or no?
Yes, sir.
I will
Yes,
solve
sir.
this by X thing. You can solve it this way also. No problem. Why? Because we are doing some ratio thing. So both things will be cancelled out. So proceed with the X thing. And that one, with that approach, no one can, say that you have done something wrong or your assumption is wrong. Please solve it. 40% completion, you understand na, 60% is left or 0.6 is left. Yes or no? 0.4x is
Yes.
exhausted and 0.6 is left. Yes or no जी बोलो दोनों.
Yes, sir.
हाँ ठीक है, करिए अब सॉल्व. फॉर्मूला में लगाइए, सॉल्व करिए. Done?
No, sir.
Stuck in calculation somewhere?
Yes, sir.
Rishita,
Yes, sir.
doing calculations?
Yes, sir.
Okay. So I'm going to solve it. Please look on the screen. Uh, so check where you have done wrong. Let's see. So KT is ln A naught upon A, right? Yes or no? बोलो
Yes, sir.
भाई. हाँ. So we don't have value of K. We don't have the value of T also. हाँ, we have the value of T, है ना? 1/40, okay? And ln is ln only. A naught upon A. A is A naught, and sorry, एक second. हाँ, A naught is X and A is 0.6x. No problem? Are yes or no? Acha, I think you people are stuck in ln thing, right?
Yes, sir.
Rishita, where you are stuck with ln thing?
Yes, sir.
To see, just look in the steps, and we are doing some calculation. In the first order reaction, most of the questions are like this, and you have to do some manipulation in the ln. Okay, so this one will become 10/6, right? बोलिए.
Yes, sir.
हाँ. So ln 10/6. Now 1/40 is equal to log of 2.303 log of 10 minus, this is whole bracket, log of 6. Okay, yes or no?
Yes, sir.
Yes, sir.
Please look into the screen. Log of 10 is 1, right? Log of base
Yes, sir.
10 is 10, है ना? बोलिए Rishita.
Yes, sir.
Let's see what is log of 6. I haven't told you to remember log of 6, right? So why? Because log of
Yes,
6
sir.
is log of 2 into 3, log of 2 plus log of 3. Okay? Yes or no? See, I have already told you to remember
Yes, sir.
log of 2, log of 3, and log of means log of 5 also. I haven't don't means I have told you not to, means not a important big deal. So log of 2 and log of 3 will be 0.3 plus 0.477. Okay, how I have solved here? So log of 2 is 0.3, log of 3 is 0.477. So this will be 0.777. Okay, can you see the steps?
Yes, sir.
Minus 0.777. Okay, yes or no?
Yes, sir.
Yes, sir.
uh, have you done this thing, or you were stuck in finding log of 6?
So
Or
log
you,
of 6. I think
acha,
No.
is.
you both were stuck in there only.
Yes, sir.
Okay, okay.
Yes, sir.
So other way to solve this is like you can simplify this 5 upon 3, then you will get log of 5 minus log of 3, है ना? So
Yes,
log
sir.
of 5, you can say this 0.7, and this is like 0.477, and just you will get the same answer. Okay,
Yes, sir.
Okay.
have you understood both steps, this one also and this one also? Please remember, if you don't know that log of m into n is log of m plus log of n. Okay, and log of m upon n is log of m minus log of n. Do you remember these this formula?
Yes, sir.
Yes, sir.
Ha. So I have applied these formula only. Okay.
Yes, sir.
Hmm. So then we are getting 2.303 upon 40 into this will become 0.33, 0.223. And then after solving this, you have to multiply and solve. This will come 1.2 into 10 to the power of minus 2. The question was asking k and it will become, see the question was asking k है ना, so the unit was minute है ना, in minutes, so answer will be in minute inverse. Okay, second inverse, not minute inverse. And this question also it was in second inverse, so the answer was in second inverse. ठीक है, here the answer will be in minute inverse. Got it everyone?
Yes, sir.
Yes, sir.
Ha, please note it down. Any problem with the mathematical calculations?
No, sir.
No, sir.
Hmm. Done.
Yes, sir.
Yes.
Hmm. Other question is uh, given t half is 2 minutes. Okay, uh, of first order reaction. First order reaction. Okay, how long will it take to reach for the reactant to 10% of its initial value? Understood the question? Here t half is given in which is 2 minutes, and first order reaction is given. Okay, and the question is asking time t when the reactant will reach to 10% of its initial value. Okay, so the if the reactant was you have taken as x, so it will reach to 0.1x. Yes or no?
Yes,
बोलिए,
sir.
है ना? So please solve this question. Can you do this?
Yes, sir.
Hmm. Again, you have to apply this formula only. Kt is equal to ln A naught upon A. Can you see the value of K is not given? The T is also not given. A and A naught is okay. It is understood. You will put here X. Here you will put
Yes.
the value of K and T both are not given. What shall you do? What do you think?
E half is given as 2 minutes for first order reaction.
Okay, then.
So we can find K through T.
Through that formula, yes. T half 0.693 upon K, right? So we will
Yes.
get the value of K, है ना? Understood, Rishita? बोलिए.
Yes, sir.
From this, sorry, T half is equal to 0.693 upon K. From here, we can get the value of K and we will put in there. Please do it fast because the time is already. Done? Please look onto the screen. Are you done till here?
Yes, sir.
Yes, sir.
है ना? So when you will solve this, you will get this 2.303 and this is value is 1, right? है ना? Yes or no? अरे yes or no जी?
Yes, sir.
So you will cross this and this, you will get like 0.3 and you will get the final answer as 6.67 minutes. Understood the problem?
Yes, sir.
Yes, sir.
Let's see one more question. So the question says that we have to prove, okay, show that in first order reaction, time required to completion for 99% of reaction is twice the time required for 90% completion. Okay. First of all, tell me, have you understood the question? हाँ जी, yes or no?
Yes, sir.
So let's see. In the first case, this is the case 1, where we are seeing that 99% is complete. Okay. So if A naught is X, A will be what? A will be for the 99% completion. What should be A? 0.01x, right?
Yes, sir.
है कि नहीं?
Yes, sir.
Means nearly everything is left, only 0.01x is left, nearly everything is reacted. In the second one case, when we will take A as X, A will be 0.1x. Yes or no? Because 90% is completed, only only 0.1x will be left. है कि नहीं?
Yes, sir.
Rishita,
Yes,
you
sir.
can ask if you have some doubts. Yes or no? Tell me. Have you
Yes, sir.
understood? Okay. So after this, you have to, this is like we have done 99%. T 99% is equal to KT. 1 upon K, KT is equal to this. ln A naught upon A, है ना? A naught upon A. Similar way, this side also. K of T 90% is equal to ln A naught upon A. Yes or no? बोलिए.
Yes,
Yes,
sir.
sir.
तो T 99% upon 1 upon K, and here we will be doing some in this value putting. So A naught is X, A is 0.01x. So we will cancel this out and this will become 100, right? है कि नहीं?
Yes, sir.
We have left this ln thing. And similarly, when we will doing this side, then it will be 1 upon K, and it will be ln. The value of A naught is X, value of A is 0.1x. This will cancelled out and this will become 10, right? है ना?
Yes, sir.
So this is like ln 100 and this is like 1 by K ln 10. Yes or no? बोलिए.
Yes,
Are we
sir.
good till here? Rishita,
Yes, sir.
can you write this as like this? ln 10 upon K? Can you do this?
Yes, sir.
Are you means aware of this rule,
Yes, sir.
Rishita? Rishita, are you aware
Yes,
with
sir.
this? So then it's well and good. ठीक है. तो देखिए यहाँ पे 2 ln 10 k है और यहाँ पे ln 10 upon k है. So this is 2 times of this, right?
Yes,
Yes or
sir.
no?
Yes, sir.
हाँ.